A warm welcome to all of you who are joining us today for this seminar, this webinar on a very hot topic. It's probably one of those blind spots we have in our communities together, which is geoengineering. And today it will be about solar geoengineering, so no carbon capture. And we have the pleasure to have with us someone who's really expert in this, so Raymond Pierrehumbert, who is both from the University of Oxford, but also from MIT. I told him that I would not try to list all the awards and nominations he had because otherwise this would take more than an hour. But let me just mention that he's a fellow of the Royal Society, and that he was also a lead author on one of the IPCC reports. He spent most of his life working on the terrestrial climate system from a system point of view, looking at how climate changes and evolves. And he has recently become very much involved as well in looking at the impacts of geoengineering, which is the topic of the day, but his spectrum is much broader. So if you look up some of his articles, it's really interesting. There are so many aspects he has worked on. It's really impressive. So my name is Theodore de Wit. I'll be your host for today. If you have questions during this presentation, I invite you to write them down in the Q&A. At the bottom of your screen, you can see a button with more, and maybe there's also directly a button called Q&A. So just write down your question or your comments, and we'll be going through them at the end of the presentation. And with that, I think it's time to start. So thank you again, Raymond, for joining us for this webinar, and the floor is yours.
Thank you very much. Yes, it's a pleasure to have this opportunity to talk to you. This is a talk that I gave a while back to the American Physical Society Global and Planetary Change Group, but nothing much has changed since then. I will give you some verbal updates on some of the latest developments as they come up, but everything that I said back in February is still on the table as a big problem. If anything, as things progress, these issues have gotten even more urgent. But why did I have train wreck in the title? Well, I've been actually looking at geoengineering for probably more than 20 years. And 20 years ago, it was something that clearly would be a disaster if it ever arrived, but the train was really way off. And even if it would be a disaster when it comes across the broken bridge of climate, it seemed a long way off. But now it's getting really close. Now it looks really imminent. And I have some Iowa connections with my family. One of our favorite family stories is the Iowa farm girl Kate Shelley. In a rainstorm that washed out the main railway bridge, had to crawl across a defunct and broken railway bridge in a massive storm with a lantern to get to the trainman to flag down the express train that was about to fall into the river with catastrophic loss of life. And she did it. And so while I can't claim to have ever done anything as brave as Kate Shelley back in 1881, I do feel like I've been waving this lantern for a long time, trying to stop the train, but it keeps on coming. If anything, it's got more cars on it, it's got more momentum, and it's moving faster. And things are now looking very, 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 very ominous. So to understand solar geoengineering and why it throws our climate so much out of whack and puts us in a completely non-analog state the Earth has never, ever been in before. First, we start with what determines the Earth's climate, what determines any planet's climate. It's the requirement that there be a balance between the amount of solar energy absorbed and that's solar energy in at the top of the atmosphere. That's the balance. The only way a planet like the Earth can lose heat, which is by radiating infrared radiation. And so when you add CO2 to the atmosphere, for a given temperature, for a fixed temperature, that reduces the rate of warming. That reduces the rate of radiation to space. And so And so in order to come back into balance, the planet has to warm up until it's balanced the incoming radiation. More solar energy reflected also decreases the amount in, which would give you a cooling because now you're radiating more than you're putting in. But these are two different knobs of climate, which affect climate in very different ways. For example, most of the solar energy for the Earth is absorbed at the surface, where it drives precipitation and gets into the rest of the atmosphere by convection. And solar energy is very unevenly distributed around the globe, and it's unevenly distributed in summer versus winter. You get no solar energy at all in the Arctic or Antarctic winter. But CO2 effects are more uniform and more global, and they come in through the top of atmosphere energy balance rather than the surface energy balance. And so while there can be some crude restoration of an energy balance by monkeying with the reflectivity, which is what solar geoengineering is all about, it doesn't put us back into a climate state anything like the original pre-industrial lower CO2 climate state. So solar geoengineering tries to make up for the change in the infrared part of the energy budget due to increased CO2 by reducing the shortwave solar absorption part of the energy budget. And I'm going to focus in this talk primarily on, and you can do that either by you can increase that reflectivity either by putting something in the stratosphere, which will persist for a year or thereabouts, or precursors that create aerosols that will reflect. Or you can actually try to nucleate clouds in the boundary layer over the ocean, and that's actually a bit harder to do because not all parts of the ocean are suitable for creating new clouds. But I'm going to focus mostly on the stratosphere, on the effects of the implications of the stratospheric solar geoengineering, although much of what I say about the problems apply just as much to the marine cloud brightening kind of solar geoengineering. So the idea is you're going to the stratosphere, so you can't do this with commercial aircraft. You need specially designed high altitude aircraft to inject things into as high in the stratosphere as you can get. The higher you go, the harder it is to get. And you put in something like sulfur dioxide that will chemically react to make particles. So there's a long distance between what you put in and the kind of particles you get and how reflective they are. That's one issue right there. But the idea is that if you take the pre-industrial climate, we had a certain amount of infrared escaping to space, balancing the amount of sunlight that was absorbed, the incoming minus the reflected. Now, what we've done by human-caused increase in carbon dioxide in the atmosphere, we've shortened, if you keep the temperature the same, we've shortened this red arrow, this infrared cooling arrow, and thrown the climate out of balance. And as we're seeing with the warming, the planet warms up, and the warmer it is, the more you radiate to space to make this arrow long again, but at a higher temperature. But instead of letting the Earth warm up, the scheme for solar geoengineering is to shorten the yellow arrow by putting in something in the atmosphere that will reflect some solar energy to space. Okay, and so we've basically hammered the climate with this one hammer. And the idea is to fix it by hammering it with a different hammer and hope that it all works out. And so you can probably cause some crude balance to restore the global mean temperature to something like pre-industrial with this, but it doesn't put us in the same state, and it causes all sorts of different geographical effects. Among other things, in the simulations of this process, the exact same injection of aerosols in different models varies by a factor of 3 in terms of how much cooling you actually get out of it. And so it's not even easy. Engineering is the wrong word because we just don't understand the climate system well enough to call something like this engineering of any sort. It's climate hacking and hoping for the best. But it's a non-analog climate. But there is an approximate analog for what is being done, what is being proposed. If you go back 450 million years ago, the sun was about 3.5% dimmer, but the carbon dioxide in the atmosphere was much higher, maybe 4 times the pre-industrial level, and that's the Ordovician. The Earth was warm and ice-free and then moderately ice-free, but no, it was not frozen over despite this dimmer sun. So in some sense, there are analogs to this kind of climate approximately, but you have to go back 450 million years to find an analog climate, and there were of course no mammals around at all at that time, and very different biota, and weren't trying to support 10 billion, nearly 10 billion people with agriculture, and even this is not really an analog climate because the sun, a star like the sun, can't suddenly flare up and get 4% brighter again. Whereas the aerosols that you put in the atmosphere would in the stratosphere would fall out in 1 to 2 years. It would be as if you were putting the Earth in a state where the sun could flare by 4% over a time period of a few years. And so we've not only put the Earth in a state that is 450, winds the clock back 450 million years, but we've actually changed the star. We've actually, in effect, changed our star to one that could suddenly flare like a low mass star, like an M star, like Proxima Centauri. So this is not in any sense restorative, a restored climate. So, and what's really alarming now, and this is the thing that has changed over the past 20 years, and it's even changed dramatically over the 10 years since I was a co-author on the first U.S. National Academy report assessment on solar geoengineering, which raised a lot of alarm bells. There's a huge amount of money. This is new for roughly the last 3 or 4 years. There's a huge amount of money pouring in, both from philanthropy and from both high-tech and financial tech industries. So some of this is funneled through philanthropic organizations that are funded by Microsoft founders and so forth, and hedge funds. So there's silverlining.org, which is largely funded. It's a pro-solar engineering lobbying organization, a non-governmental organization that testifies to Congress to promote actual deployment of solar geoengineering. And they get a lot of their money from Silicon Valley donors. There's the Simons Foundation, Renaissance Capital, which is in their second round right now of $10 million of annual funding for research on solar geoengineering. And even the Environmental Defense Fund that's not Électricité de France, that used to be Environmental Defense Fund. They're now an NGO that just called Environmental Defense. They've accepted what's called millions in press releases from the LAD Climate Fund, which is another one of the industrial tech industry funders. And I wonder how the grassroots donors for environmental defense think about this what would be a major assault on the environment. There's the Degrees Initiative, which is funded by Open Philanthropy, which is largely bankrolled by Facebook money, which purports to be an educational effort. But when I look at what they actually do, they seem to be essentially recruiting people from the developing world, dangling money for them to do research, and the research rarely, and what this does is create stakeholders in the developing world to advocate for at least a more expanded research program in solar geoengineering. And I'll point out shortly why the claim it's just research is not actually very comforting. In fact, especially the kind of research we're getting now does not answer any of the important scientific questions, but threatens to develop technology that some rogue trillionaire, we have rogue trillionaires now as well as rogue billionaires, might actually decide to deploy, or some rogue country. Okay, the Quadrature Climate Foundation is giving $40 million. Funds have gone to University of Exeter, University of Colorado, funneled mostly through Silver Lining. Okay, the University of Chicago, in its not so infinite wisdom, is pouring massive resources into the Climate Systems Engineering Center. to promote solar geoengineering and solar geoengineering research, among other things. And this was an initiative that was recommended not by Earth Science at University of Chicago, but recommended by the economists who had the ear of the new president a few years back, led by David Keith, hired away from Harvard. And they've actually, initially at least, promised 10 full-time faculty slots devoted to the center. That's a huge effort that could be much better deployed on more fundamental climate problems that actually could help the situation. And it was created essentially without any consultation with the Geophysical Sciences Department, though it's housed there. That's really put a lot of money into the field. And now in Cambridge, England, there's this absurdly named center called the Center for Climate Repair, which has gotten 10 million pounds from NERC, the English research agency, and it's gotten additional funds from ARIA, the Technology Development Agency, which I'll get to in the next slide. And actually, alarmingly, funds not just numerical experiments, which are relatively innocuous, but it funds real outdoor experiments, including experiments outside the United Kingdom and in Canada that are done in collaboration with for-profit companies that are seeking to actually patent and make money off of these various schemes. This is an example of their so-called sea ice thickening project, which is actually underway right now. You might have seen that there's a rather over-the-top gee whiz article about these people in The Guardian yesterday. So ARIA is the Advanced Research and Innovation Agency in the UK, which was cooked up by the previous Tory government as a kind of a lookalike for the American DARPA project. It's run by inexperienced directors. It's not subject to freedom of information requests. It's run largely in the dark, and the directors have complete carte blanche over what they spend their money on. And they have this. 2 years ago, they put 58 million pounds into a geoengineering project called Exploring Climate Cooling, which alarmingly is aimed at developing technology, not answering scientific questions. So this is the worst kind of research if you're going to have research on this. It's research that develops technology that somebody like a for-profit company might decide to deploy without answering any of the serious scientific questions about what might go wrong if you actually did deploy it. Okay. What kinds of things is ARIA funding? They're actually funding expanded field trials of marine cloud brightening over the Great Barrier Reef. And while sometimes marine cloud brightening is thought of as something that's just a local patch that doesn't affect the globe, there's no such thing as anything really local when it comes to climate. All parts of the climate system are connected. And in order to actually substantially cool the Great Barrier Reef, you have to actually deploy marine cloud brightening over a very substantial area. Otherwise, you just get warm water and warm air flooding in from outside. So that has global repercussions, both in terms of patterns of rainfall and temperature, as well as local repercussions. They're funding an aerosol disperser engineering for marine cloud brightening, including field tests, and that's in collaboration with for-profit corporate partners. You're seeing more and more for-profit interest in this. Archipelago Technologies is involved in that. So they're funding sea ice thickening in the Canadian Arctic in collaboration with two for-profit partners, Real Ice and Arctic Reflections, and also funding the engineering of particles for stratospheric aerosol injection, including in situ balloon board experiments, which don't actually release the particles, but it's the next best thing to that. They're actually putting things up into the stratosphere. Okay, and also they're funding engineering design of orbital sunshades, which, given cost to launch right now, is completely money down the drain. Okay, but now the most alarming thing, without even any government buy-in or philanthropic buy-in, the Israeli solar geoengineering Stardust has gotten $70 million worth of venture capital funding. They describe solar geoengineering as a safe, measurable, adjustable, and fully reversible system to stabilize Earth's temperature. And their pitch deck to investors leaked to Politico, and their business model is to sell engineered aerosols to companies that and governments that would do geoengineering, and they would make their money off of that. And their business model assumes not just research, but assumes that this stuff will actually be deployed, within a decade or thereabouts. This is just the thin edge of the wedge on venture capital funding. All this is happening in the absence of any governance. There's no governance at all that actually limits any of these activities. Maybe most of the new funding is not for addressing fundamental scientific questions. It is actually funding for developing the technology. And no matter how well-intentioned the scientists or engineers doing this research are about the kinds of deployment and whether it's deployed, the decision about deployment once they develop the technology is not in their hands. Those decisions will be made by other people. It's like the Manhattan Project, where they developed nuclear weapons. They hoped to have some control over what happened after the end of the war, but they had no control. It just passed to a completely unstoppable, in that case, government bureaucracy. In this case, it may pass into the hands of people like Elon Musk, for all we know, or other would-be trillionaires. Okay, and these questions about what would actually happen in a full-scale deployment are probably unanswerable unless you actually have a full-scale deployment. And even then, because of interannual variability and fingerprinting difficulties, it could take many years before you even knew what we had actually done to the climate. And is it really wise to do so much engineering research that will make deployment technically feasible without any governance in place to constrain how the technology will be used, or if? So if you just look at what happened with AI, initially, even with open AI, there were all sorts of pious claims that we will do this in a safe way, we will go slow, we will use the sort of benefits of mankind. But the big once profits were perceived, and they haven't achieved profits yet, but once big profits were perceived and big pots of venture money were pouring in, all possibilities of significant governance of AI flew out the window. And I fear this is what's about to happen with solar geoengineering, unless we get on top of it right now before it is a major, major target for venture capital. Okay, one problem is, one reason you even see some respectable atmospheric scientists advocating or edging towards advocating for research on solar geoengineering is that there is a legitimate panic about how slowly we're making progress on decarbonization. The feeling we have to do something. But yes, it's panic time, but the response to the panic is to double down on the rate of decarbonization. And it is a hopeful time for that, because renewables have never been cheaper. Even in the US, despite Trump, renewable solar is now generating more power than coal, which would have been unthinkable just a few years ago. And the renewables, especially photovoltaics, are coming down in price very dramatically. They're already cheaper to produce cheaper energy than any fossil fuel energy, including natural gas. And they make countries, and photovoltaics, renewables make countries less subject to oil shocks, fossil fuel shocks, like we're seeing through the closure of the Straits of Hormuz right now. So yes, there's a reason for panic, but that does not mean that. What that really means is that we should be doubling down on deployment of renewables, which is necessary for national security reasons now, completely apart from climate. Okay, and much of the research, so some scientists say it's just research. We're not talking about deployment, but as I said, much of this research actually fosters the development of deployable technology. Once the technology is developed, the genie's out of the bottle, and it won't be the scientist's decision about whether to deploy it. Do you really trust this technology in the hands of Vladimir Putin, Donald Trump, Elon Musk, and so forth? Okay, now here's the biggest thing. You often see solar geoengineering argued for, promoted as a way to so-called buy time for future decarbonization. But that couldn't be farther from the truth. And to understand that, you have to look at the mismatch in timescale between the persistence of CO2 in the atmosphere and the persistence of engineered aerosols in the atmosphere. Why is buying time such a fallacy? Well, it's because carbon dioxide is removed only very slowly from the atmosphere. In fact, over thousands of years. So any continued emission of CO2 accumulates in the atmosphere, leading to ever increasing warming. And universally, what's found from simulations in climate physics is that the amount of global heating we are left with at the time net zero emissions are achieved is what we're stuck with for thousands of years, pretty much for at least 100,000 years. So in some sense, once you've emitted CO2, barring major technical breakthroughs in air capture, you can't unemit it. You ratcheted up the climate irreversibly. And so it's not a matter of just being able to deploy solar geoengineering for a few decades, and then finally we get our act together to get to net zero. That's not the case. The CO2 will still be in the atmosphere even 1,000 years from now and more, still causing warming. And so if you start needing to do solar geoengineering, you are stuck doing it essentially forever, or until finally some technology is developed to suck CO2 out of the atmosphere. But here's an example from a 2016 paper 10 years ago that I was involved in along with a dozen other people. This is based on both past climate records, proxy records, and instrumental records, largely proxy records, and computer simulations of the future. And many people have done more sophisticated climate simulations of this sort since 2016, but they with very minor changes in the climate sensitivity, they give you the same story. And so the top graph is the carbon dioxide. Let me just take a peek at my timer here. Yeah, okay. Yeah, the top graph is carbon dioxide in the atmosphere versus time. This is 20,000 years ago in the depths of the last ice age. Carbon dioxide because of enhanced ocean uptake, it's believed, had dropped to 180 parts per million from its pre-industrial value. And as we came out of the glaciation 10,000 years ago, it rose to about 280 parts per million and hasn't really changed very much over the whole 10,000 years of the Holocene, the rather stable climate period when civilization and settled civilization and agriculture arose. And if I look at the past, the global mean temperature, it was about 4 degrees Celsius global mean temperature cooling back in the depth of the last ice age, and then we had some little wiggles coming out of it, and we entered the Holocene. And actually, because of changes in the Earth's orbit and the Earth's precession, we've actually been on a natural cooling trend, a very slight cooling trend through the Holocene, but it's been very, very small. And that cooling trend ended when we started the Industrial Revolution and started pumping CO2 into the atmosphere. And this was dot is 2016, the CO2 level, which had reached somewhat over which had reached 350 or so parts per million. And then these different lines on this graph are how much cumulative carbon, how many tons, how many gigatons of carbon in the form of CO2 we release in the future by the time we get to net zero and stop emitting carbon dioxide. And so this, for example, is a little over 1 trillion tons, metric tons of CO2. That's a low scenario, but we're closing in on that pretty quickly, and it goes up to say 5 trillion tons here. Okay, so the CO2 peaks in the atmosphere peaks very shortly after we stop emitting. In all these scenarios, we stop emitting, right about near that zero for now. And then the CO2 gradually declines. And the decline really stops after 1,000 years or so, when the ocean has almost finished taking up all the CO2 it can. And then the CO2 is pretty flat. But although there's a decline of CO2 in the first 1,000 years, the temperature stays pretty fixed. And that's because over the first 1,000 years, the oceans are still warming up to come into equilibrium with the CO2 already there. And the rate of ocean warming is about the same as the rate at which the CO2 is coming down, because it's the same processes that are exchanging both heat and CO2 with the atmosphere. And that leads to a situation where the temperature remains fairly flat out to 10,000 AD. So we're basically resetting the climate for the whole Anthropocene, all the future. And in fact, if you extend this out, natural silicate weathering reactions will take 100,000 to 400,000 years to bring this CO2 back from this 10,000 AD value to something like pre-industrial, unless we actually tip into a completely different climate state where you never actually get back in. So this is why the buying time by geoengineering is a fallacy. If any delay in reaching net zero increases the amount of CO2 that we burden in the atmosphere, and we're stuck with that for essentially the entire future of humanity. And now, what happens then if you have canceled out that 2 degrees or 3 degrees or 4 degrees of warming by solar geoengineering? Well, this is one example. This is an example of what happens if you let CO2 continue to accumulate, but you then balance it out with ever greater degrees of deployment, greater magnitudes of deployment of solar geoengineering to close this gap and bring the temperature down to a sort of the fixed pre-industrial temperature. And this shows what happens if you then terminate solar geoengineering in 2050, for example. You rapidly, over just a few years, come back up to the line of where you were. And so you turn a gradually unfolding catastrophe into something that's more like nuclear war, where you're suddenly hitting the world with 1.5 degrees of warming. Here you're suddenly hitting the world with 2.5 degrees of warming. And the longer you go on relying on solar geoengineering, the bigger the catastrophe waiting in terms of termination shock. And this is just global mean temperature. This is the same thing basically done with several coupled ocean atmosphere models. There's been so little work on termination shock that in the Royal Society report on solar geoengineering that just came out recently, they didn't even find any. They used this exact same graph which we used in our 2016 U.S. National Academy report, because of all the research people are doing in figuring out how to deploy solar geoengineering, nobody has taken another look at what these catastrophic termination shocks would do on a regional basis. For example, if gradual global warming is bad, global warming that unfolds to the tune of 2 or 3 or 4 degrees over a few years is really catastrophic for things like ice sheet breakdown, because you form big pools of meltwater, among other things. What does it do to hurricanes? What does it do to monsoons? There are all sorts of catastrophes lurking just in what this termination shock would do. And if there's anything that needs more research, it's not the engineering aspect of geoengineering, it's the actual impact of catastrophic failures like this. Okay, and so this is connected to the problem of what I call millennial commitment. If you need solar geoengineering to keep temperature from rising to dangerous levels, you're really committing future generations to maintaining solar geoengineering without fail, essentially forever. And some people say, well, we'll do large-scale carbon dioxide removal as an exit strategy, but that technology doesn't exist. It may never exist. And so to deploy solar geoengineering at a time when we don't know if carbon dioxide removal will ever be scalable to what we would need, it's like jumping out of an airplane and hoping that someone invents a parachute before you hit the ground. And it just does not buy time for decarbonization. It's not a plan B in the case the world fails to bring CO2 emissions to net zero, because as I was implying in the connection with the termination shock, the longer you continue emitting CO2, the more geoengineering you need to balance out the accumulated CO2 in the atmosphere. and the bigger the termination shock you're stuck with. And at some point, the geoengineering is going to start to have really catastrophic side effects, even if you don't have a termination shock. Okay, and I've already talked about the problems with relying on carbon dioxide removal. And so another myth in solar geoengineering is that the proponents say, well, okay, well, just do a little bit of trimming. Maybe when we finally hit net zero, it'll be 2 degrees. You'd rather have it at 1.5 degrees. Well, first of all, we're not anywhere close to hitting net zero yet. So that's a bit of a fantasy right now to begin with. I'd buy this argument more if we were actually getting close to net zero, or at least on a track for it. But also, I just don't think that the world is in a state where it can make an agreement to say just do a little bit of solar geoengineering and not let the cat out of the bag and just do unbounded amounts. If you just look at the fate of international agreements right now, even on things as sensible as nuclear arms control, nuclear non-proliferation, the idea that the world is in a political state where this could be done, that's just completely ludicrous. Okay, kind of restraint's just not realistic. Okay, and I highlight termination shock, but there are all sorts of other problems lurking in these non-analog climates. Low cloud dissipation from direct CO2 effects, as Tapio Schneider has pointed out, could have unknown consequences. Unknown global cloud feedbacks, including mysterious hemispheric symmetry of solar absorption, of the top of atmosphere radiation budget. Asymmetric solar geoengineering is known to clobber sub-Saharan precipitation, cause major droughts. And then there are aerosol effects that affect the stratosphere differently from the troposphere. And largely unexplored risks from termination shock, as I mentioned. So humanity, coming to the end now, humanity is really facing a fork in the road. And one of the best illustrations or prods to the imagination about this fork in the road that we're facing in humanity right now is actually from an alternative history timeline in the science fiction show Star Trek Picard, where Q goes back and changes the past in a way that brings about a less equitable future for humanity. And the Enterprise has to go back and restore the timeline. When they go back 400 years, they find not the green, verdant world, but something that is encased in a solar geoengineering web, in a polluted and unlivable world on life support. And Q, talking about the year 2400, said humanity had found a way to save the planet they were murdering, but in this timeline, they just kept the corpse on life support. Okay, and that is a direction we're unfortunately heading to right now. That is what we're going to get unless we get serious about net zero. And and there is, the reason we're at a fork in the road, there is reason for hope. There's the drastic reduction in the cost of renewables, especially photovoltaics. In 2025, solar and wind passed coal as a global energy source. China emissions have been flat or declining because of rapid renewable rollout, and Africa is leading the world on solar energy growth. For all these reasons to be hopeful on a technological front, you can see the book Solvable by my colleague Susan Solomon here at MIT. But the other side, the despair side, we have first and foremost right now is the rampant fossil energy gluttony by AI data centers that threaten all the progress that is being made in deployment of renewables. US data centers are projected to grow to 10% of the electricity demand by 2030. And I think the newest estimates are slated for even more growth. And they're driving a huge surge in fossil fuel gas-fired power plants, especially in the United States, but not just in the United States. But as an example, Meta's Louisiana fossil fuel data center will require the build out of 3 whole new gas-fired power plants. And there's an alignment of interest between tech oligarchs who don't care what they break, including the climate, as long as there's money to be made, and so-called climate repair techno-optimists who are largely funded by the same high-tech industry, who think they'll be able to somehow fix whatever the tech oligarchs break. And so this is our fork in the road right now. and AI data centers are part of what's driving this, though not all of it. Uh, we have some one fork, which is the utopian fork, where insofar as AI eventually proves useful for some things, it makes life better for everybody. Instead of destroying jobs and making a permanent underclass, it gives people more time for enriching themselves and a more better work-life balance, more time with family, and so forth, rather than massive unemployment. And that AI and other energy needs are done with abundant renewable energy build out, leading to a clean environment. But the other thing, and this is almost a quote from the head of OpenAI, who wants to carpet the Earth, thinks the Earth is going to be carpeted with data centers, unrestricted CO2 emissions, a concentration of wealth and oligarchs, most people unemployed and impoverished, and the few who are left with jobs overworked, and all of them suffering the existence of a planet on life support with constant fear of termination shock. And what is to be done? Well, you have to learn, people should need to become aware of what's going on, that write to legislators, raise a ruckus. And one simple thing to do, just as a starter, especially for the scientific community, is to sign the letter calling for a non-use agreement, a moratorium on solar geoengineering, which embraces not just the deployment of solar geoengineering, but the kinds of research that develop the technology without answering scientific questions. It's not opposed to all kinds of research, but basically research that leads to deployment is opposed, as well as actual deployment here. And so if you go to solargeoengineering.org, you can click on the Take Action button. You can add your name. This is also a resource where we post a blog. We have a blog where we post late-breaking developments and analysis of various solar geoengineering developments that are longer, articles that are longer than we can fit in the typical op-eds that we write. So thank you very much. That's the end of what I had to say to you today.
Well, Raymond, thank you so much for this presentation. Um, it will take some time to digest everything because it comes as a shock as well. I thank you as well because it was both scientific and also clearly non-neutral, because you really advocated the position we should take for this. Let's go through some questions. The people who are in the audience, if you have questions, please write them down in the Q&A, and I will go through them. I will read them. In the meantime, I have a first one, which is mostly scientific. You talked about cloud nucleation as one of the solutions over oceans. So what is the purpose here? Is it just to increase the albedo over oceans? But then you also change the precipitation patterns and
Yes, yeah. So the cloud nuclear. Yes, the idea is that for a given mass of water, that you condense, because of the properties of Mie scattering.
Mhm.
If you make a lot of small particles, it's more reflective than making just a fewer big particles. And the number of particles that you make when you condense is more or less determined by the supply of cloud nucleation particles. And so people propose to evaporate seawater and use the salt particles as nucleating particles to brighten the marine clouds. And the problem with it, it does also change the marine precipitation. But a bigger issue is that it's really hard to know where the addition of nuclei will actually affect the clouds, because in a
Mhm.
lot of places there are plenty of nuclei anyway. But one of the big issues with the marine cloud brightening is that it can't be deployed uniformly over the ocean, just in some places where you're close to
Exactly.
making
Yeah.
clouds.
Yeah.
And so you have this very regionally inhomogeneous forcing of the climate, which is going to disrupt all sorts of circulation patterns if it's ever done at
Okay.
scale.
And I can imagine there'll be lots of legal aspects. I mean, if you
Yes, yes. Well,
cause
that's
such a big.
another thing. I mean, it's hard enough to attribute aspects of something like a heat wave to CO2, even though we understand very, very well how CO2 affects climate. And so
Mm,
if you have a dispute between two countries about the effect of geoengineering, who is equipped to adjudicate that dispute? It doesn't even have to be a true effect. If India
mm.
claims that some Australia's solar geoengineering has disrupted the monsoon, whether or not that's actually true, it still causes international tension. And
Of
when
course, yeah.
can we, how you actually adjudicate those sort of things when our models are really pretty imprecise with regard to
Mm,
a lot
mm.
of these tropical circulations.
So, a different question. In the Meadows report, the famous Cap de Rome report in 1972, one of the strong statements they make is that if we try to delay some of the tipping points, if for some reason we can delay tipping points until later, actually
Yeah.
it will make the system even less tractable because they can flip one after the other. So I understand that basically you're seeing the same pattern. Is that
Yeah,
correct?
so actually, and I would add, well, first of all, I mean, the tipping point argument has often been used. In fact, it's been used by ARIA as part of the justification for their funding
Mm,
of geoengineering. Yeah, and some people say, well, we have to really take drastic action to avoid tipping points, but there's a whole mathematical literature on so-called rate-induced tipping where tipping some bifurcations are triggered by the rate of change of a forcing variable. And so
mhm,
if you think you're going to trigger a lot of tipping points by relatively gradual warming, you have much bigger risks of causing some kind of catastrophic tipping that you wouldn't even see coming in advance by if you have this rapid warming from a termination shock. So
mhm,
it's actually setting us up. If you think you know where these tipping points are, which is something we don't actually know for the most part, if you think you know where these things are, you're actually increasing the chance of having cascading tipping points out in the future because sometime over the next 1,000 years, it's almost inevitable that something is going to happen to society that's going to
mhm,
cause a termination shock, and it might happen at a time when the world is suffering other
mm.
stresses like plagues and nuclear warfare or what have you. And so that actually is setting the Earth up to be much less resilient.
Okay. So, assuming that we decide to go for solar geoengineering by using sulfur dioxide, has anyone tried to estimate to compute the given the number of flights you need, an increasing number, if we stay in a business as usual model, how long could we potentially survive with that model? I mean, all the energy and the material and in a world
Yeah.
with less resources. I guess this has been estimated, or
Well, so actually, what hasn't, the estimates have been done for, say, what it would take to say cancel out 2 degrees
Mm,
of warming. I don't think people have pushed it to the scenario where we are continuing to emit CO2 and doing more and more each year, because at some point, the stratospheric geoengineering stops being effective because the particles start to aggregate and fall out faster. And so,
oh, okay.
the physics behind that is difficult, and it's a matter of contention. Just what is the ultimate limit on how much you can get to? But generally speaking, if you're looking at something like creating an albedo increase to cancel out 2 degrees or so, although there's uncertainty in how much you need to inject to do that,
Hmm.
the thing that makes it alarming is that the cost is not a showstopper.
Mm,
Or orbital mirrors, the cost is a showstopper,
mm,
even with the reductions in cost to launch orbital mirrors or star shades. That
yeah.
that 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 that's just way too expensive. and things like the proposals to dam up the Bering Strait to restore the thermohaline circulation. That's way too expensive. But what makes geoengineering alarming is that if you do the back of the envelope costs, although they're probably greater than people are anticipating, the costs come out to be not large in comparison with the world GDP. So
Hmm.
if this were something that couldn't be deployed because it was outrageously expensive,
Hmm.
I would be less worried about it because just
Yeah,
the
yeah.
cost would take care of things. But unfortunately, it's not. It is something that even a single country could actually afford to do.
Mm.
There's a lot of parts of the cost that haven't been taken into account, and issues that, like, what if some country doesn't like the effects of your geoengineering and starts shooting down your aircraft?
Hmm.
Or what if other countermeasures are being taken and that requires you
Hmm.
to do more? What about the whole monitoring infrastructure you need? You need something of the whole World Meteorological Organization just to monitor what you did. We don't
Mm.
have that monitoring in place adequately
Yeah.
right now. So I think there are unanticipated costs, but it's just hard to make a case that economics alone
Mm.
would prevent this from being deployed.
Mm.
And,
Okay.
and that's
Uh,
actually in physics. I mean, it's something I use in my climate classes. What is the radiative forcing per kilogram of SO2 versus the
mm.
radiative forcing per kilogram of CO2. And it just has to do with the radiative efficiency of
Yeah,
condensed matter. It's just optics.
yeah. So just to follow on, and there are a couple of other questions to follow on that. In Elizabeth Colbert's book Under a White Sky, she has this very stunning image that the skies, we won't see blue skies anymore, but the skies will be mostly whitish. And I guess this has also a psychological influence. Has this been ever looked at? The
Well, actually, I
psycho.
don't know about the psychological influence of that. There is concern about what this would do to ground-based astronomy, which hasn't been well quantified, but is something I'm actually looking into. Right,
Mm.
I'm actually looking into right now because there are still things that we can do from ground-based telescopes that we can't do in outer space
Yes.
yet because of power requirements and mirror size. But actually, the white sky image is very important for the physics and impacts also because when you increase, just I'm just trying to turn off my timer
Mm.
there. Yeah, when you put in some aerosols to increase the reflectivity, that actually does two things. Because aerosols scatter light in all directions, almost
Ah,
isotropically, and so
oh.
the sunlight comes in as a direct beam, all from one direction, essentially.
Mm.
And so when the aerosols scatter, only a small portion of that is scattered back to space. And
Mhm.
so if you scatter 1% of the energy back to space, you actually turn a much higher percentage into diffuse radiation, which is the white sky
Yes.
business.
Yes.
So that in itself affects vegetation because
Mhm.
different kinds of plants respond differently to direct sunlight versus diffuse sunlight, and also
Mm.
solar thermal plants that rely on mirrors to
Mhm.
concentrate solar energy don't work with diffuse sunlight. So you
Of
actually cut
course.
off
You,
solar. You've actually made every world solar thermal plant less efficient. Photovoltaics don't care very much, but then there is the psychological aspect. Every day you look up and you not only see this white sky, which is the sign of putting the corpse on life support, but you
mm.
know that if someone stops maintaining that white sky, you're going to be facing
Yeah.
a
The depth.
catastrophic warming.
Yeah.
I grew up in the depth of the Cold War when people were building fallout shelters in their backyard and hoping to be the few survivors for whatever reason, and it was terrifying. But this I see this living under a termination shock is in some sense even more terrifying than the thought of nuclear war because it affects every single square inch of the
Yeah.
whole Earth.
Yeah. Mm.
So there's a failure of imagination right now in just how bad it would be how terrifying it would be to be living under this perpetual threat of termination shock. And that's why I've started trying to bring in some things from Star Trek and so forth as a sort of a jog to the imagination. We just need more imagination about it's not purely technical. What
Yeah.
is it actually like?
Mm.
You know?
So here I have a a different question. I'll read it. So in his latest encyclical, the Pope Leon XIV, wrote on safeguarding human dignity in the age of artificial intelligence. So
Yes.
you have shown the deployment of data centers and geoengineering are two faces of the same coin. So would it be possible to show to the public and maybe also to influential people like the Pope that both should be considered, an ethical use of AI and a scientifically founded research of what geoengineering entails?
Yeah, actually, I'm a great admirer of the Pope's new encyclical.
Mm,
I've read it quite carefully, and although he does not mention, he mostly is concerned with human dignity, but
mm,
he does actually mention the environmental impact. He does
mm,
not of data centers, and I think actually bringing this sort of this aspect of the push towards
mm,
the push towards growing data centers and canceling out their effects with geoengineering is part of the dystopian vision
mm,
that the Pope is referring to, although he doesn't specifically mention the geoengineering aspect of it. And oh yeah, I have no even though both the Pope and I are from Chicago. I don't have any direct line to the Pope. I have been at meetings in the Vatican, but only for astrobiology, not for
mm.
Earth climate. But I am looking to organize some event at Oxford about built around the Pope's encyclical on AI, which would be a good vehicle for
Wow.
that if we can bring that off together with one of our chaplains at one of the colleges and so forth.
Yeah.
But yes, it is a natural lead on to the Pope's theme of
Yeah.
preserving human dignity in the era of AI. And
Yeah.
so,
Yeah.
yeah, I'm all for it.
Mm.
If you happen
That's
to run into him, please
congratulations.
send
Yeah.
him
It's
my regards. Yeah.
yeah. I think
But
it's
it
important
actually
to.
would be, yeah, it actually would be good to have a Vatican study group
Mm,
on the joint problems of environment and
yeah.
AI.
Yeah.
And I do know some people in the Vatican Academy that I might be able to prod into
Mm.
that. So, yeah.
So a somewhat related question in our community, I mean, in the community of people doing space science or working on satellites and sounding rocket launches, and so there's now a growing awareness of the environmental cost of having a launcher. People are less aware of the environmental impacts of rocket exhaust and debris, even less so of geoengineering and the Kessler syndrome.
Yeah.
So, how would you? This is a difficult question. How would you suggest to inform the community and get them more deeply involved? Because some people are aware of it, but the vast majority doesn't even know about it. So it's
Yes, you're completely right that more people need to know about it. And Um, we need more people giving talks like this to parts of the scientific community because other people have different perspectives and can bring different aspects of their expertise. For example, I don't know much. I know that evaporating satellites that re-enter put a lot of stuff into the upper atmosphere.
mm,
I don't really know what satellites are made out of, and I don't have the
mm,
expertise to say how that might be affecting the upper atmosphere, things like that, or rocket exhaust
mm,
for launches. Although, I mean, already the Wall Street Journal did have an article pointing out that that rocket exhaust from increasing launches into low Earth orbit is, in some sense, an inadvertent geoengineering experiment
indeed.
in
Yeah.
itself.
Mm,
That focused more on the soot, which actually can have a cooling effect
mhm. And black
on the
carbon.
lower
Yeah.
atmosphere. So, but basically, I still feel like there are only a few people I know in the scientific community who are actually speaking out about this and educating themselves and writing op-eds and talking to professional groups. I mean, I know a lot of almost everybody I talk to is nervous about the prospect or dislikes the prospect of solar geoengineering, but relatively few are really. I sometimes feel like it's the same dozen or so of us that
Mm,
are writing the op-eds or so, and so I would very much like to have more people just engaging in one way or another. And there there are lots of ways of doing this. If you're a member of the environmental defense, the leadership has to really hear from the membership that supporting geoengineering is just not an acceptable thing or not a good way out. But education is where it starts, and I would just like to see more members of the
mm,
scientific community, especially related to atmospheres, speaking out about this sort of thing.
mm,
And so it is frustrating writing op-eds. For every 5 op-eds I write, maybe one of them actually gets published somewhere, but then I fall back on expanding them and putting it on blogs, or I get articles
yeah.
into the Bulletin of the Atomic Scientist. So it takes a lot of effort, and it's pretty wearying because what I really want to be working on is my James Webb Space Telescope data.
Hmm.
This geoengineering stuff, it will not wait on the back burner. It's just moving along very fast.
Yeah.
So
Yeah.
yeah. People need to write to their legislature. I did manage to get a whole parliamentary hearing in the UK about the ARIA program, but it did not lead to any cuts in the
Really.
ARIA of funding. It seems not to be a priority of the Labor government right now, even though it was a
Mm,
Tory initiative. But it is frankly hard to figure out just what is the priority of the Labor government right now,
mm,
apart from surviving. So
yeah.
yeah.
Yes,
But
indeed. So.
it takes a lot of concerted action
Mm,
by a lot of people, and we're doing this with almost no funding. So,
mm,
while hundreds of millions of dollars are now going into pro-geoengineering lobbying and
mm,
technology development, this solargeoeng.org, we're running on about $10,000 a
mm.
year or so forth. So it's a shoestring, and it's a struggle to maintain even that. So.
So I had one last question. I think this is the last of the list.
Mhm.
For early career scientists, if I think it's not very fancy to propose a topic on that, so first they need to get a permanent position.
Yeah.
So how would you suggest or encourage them to engage in such issues? Because they have to eat, but they also want to follow their
Yes,
their
yes.
heart.
Well,
Yeah.
well, first of all, I would not uh, encourage any early career scientists to try to make a career out of solar geoengineering.
Mhm.
I think as people become more aware of it, it's probably going to the tide is going to turn eventually. At least there will be backlash against these proposals once word actually gets out about what it would actually mean. Although there is funding at University of Chicago, for example, for faculty lines in this area, I wouldn't really counsel a young person to hook their wagon to that particular star. On the other hand, there is research that needs to be done, among other things. There's research that needs to be done on fundamental climate processes
Mm.
that actually would help us understand the impacts,
Yeah. Yeah.
and that includes things like better monitoring of the Earth's radiation budget, how you actually do that. And it also includes things like simulation, understanding what's really happening in simulations of termination shock. That is an
Yeah.
area
Yeah.
of research that does not develop the technology, but would
Mm.
actually would give us at least some ideas about how bad it would get.
Mm.
And so, but it is possible for an early career person to spend some of their time writing letters to the editor and writing to
Mm.
their congressmen, their
Mm.
legislators. And I wouldn't want it to become as consuming and obsessive as I've gotten. Although even for me, I doubt that I'm spending more than about 10% of my time on this solar geoengineering
Mm.
stuff. The
Mm.
rest of it is on more fundamental Earth climate and
Yeah.
exoplanet climate questions. But,
Okay. Well, with that recommendation, I think
okay.
I would like to thank you again very much for this presentation. I think it was really important that we hear this message, and
Yes.
we will try to keep on propagating it. So thank you again very much.